Thank you so much for joining us today for AI sustainability using free satellite data for good. We will be having a Q&A with our instructor, Shalini Ananda. Dr. Shalini, who is a machine learning specialist, entrepreneur, product developer, and our AI instructor here at UC Santa Cruz Silicon Valley Extension. Here at our Silicon Valley Extension, we do professional education, where we are the leading workforce educator in the Silicon Valley as the only accredited institution in the area to offer University of California quality courses designed specially by our experienced instructors who actually work in the field. My name is Maira Hernandez, and I'm the recruitment growth specialist. So I'm here really to help with any questions that might come up. On the chat, feel free to drop any questions or any commentary you might have throughout the presentation. And I'm also here to help in case anybody has any questions about enrolling in any of our classes. And if you do have any questions for future reference, you will see the phone number and extension email. I will also drop it in the chat so that way any questions come up in the future, you have our contact information. So with that, I do want to move on and introduce our instructor. So Dr. Shalini Ananda, she has a BA and MA degrees in mathematics and her PhD in material science and engineering from UC San Diego, has been involved in machine learning since 2011. Her recent projects include products in healthcare, 3D printing, music, and climate change. Has founded 2 startups in machine learning space for CRIX Labs in the pharmaceutical space and a company in 3D printing. Also teaches at UC Extensions using Roblox to teach students programming, participating in an X Prize challenge to measure if blended learning is effective, and teaching growing food on Mars. And the new course is AI for Sustainability using satellite data, which is a 10-week course, starts in July for a total of 3 units. So I'm going to hand it over to Dr. Shalini, who will continue on with this presentation.
Awesome. Thank you so much, Myra. All right. So discussing AI for sustainability, and we're using free available satellite data. So and it sounds like a lot of you guys are super duper experienced with free data sets. So who here has used JEDI from NASA or Google Earth Engine's freely available satellite data? Please write on chat, or you can just raise your hand. Awesome. So can you tell me what you used that for?
JEDI I've only used once. It was to help a UNDP project a friend was doing in an island off of Africa to look at carbon tracking. It's a really interesting data set, different for me because it gets data along a track, but then you have to figure out what's going on in between the tracks. And Google Earth Engine, actually, I go pretty way back for that. When I used to be faculty, I did a project with Google Earth Engine, so I've known about it since the origin. I kind of consulted on the original team that was designing it.
All right. So the idea of this class is to really use machine learning techniques to answer critical questions around sustainability. So this is essentially a computer vision class. And we're going to use some of the latest tools in computer vision to look at satellite images, but we're all going to answer one critical question. The way this class works is you're going to find your own question. So you're going to do your research and find a critical question that you want to answer, and we'll basically I will guide you through that question to answer or to come up with ways to answer that question. I know this sounds pretty abstract at the moment, but I'll give you a simple example later in the presentation. And always with machine learning, we have to have the right metrics to evaluate your model. At the end, hopefully you have something on GitHub that you can produce, and almost a GitHub paper, as it were, that you can show potential employers, your colleagues, friends, whoever. And you will also present this capstone project to the class, and hopefully we can also learn more about this sustainability problem. All right, so let me pose a question to the audience. What does sustainability mean to you? So a lot of you guys said you're interested in this class because it had the word sustainability. So in chat, or you can even raise your hand. What does sustainability mean to you? Making the things we do every day have lower impact on the environment. Awesome. Thank you, Paul. Do no harm or less harm. Awesome. Thank you, Jennifer. Thank you, Bill. Being able to meet current needs without impacting future generations or exhausting resources. All great answers. Generating the data in an energy saving way. Yes, saving way. Yep. All correct. All right. So do you guys mind if I move on? So we'll go on to the next slide. All right. So what is your question for the planet? That is what we're going to ask in this class. So you're going to formulate a problem in climate change. You're going to look at the data we have. Then you're going to come up with a method or solution using machine learning to help answer your question. And we're going to assess if based on your data, you're able to tell a story. Because ultimately with machine learning, sounds like a bunch of mumbo jumbo to people that are not machine learning experts. So that is one of the key, it's called machine learning or AI explainability. So that is a key part of this class where you're going to be able to explain what your results say. And, even if you used a fancy machine learning method, how do you explain it to somebody who is not a machine learning expert? So this is a question I asked. Do people resettle after a fire? So I know we live in California, and I personally was affected by the Big Sur fire. So I was living in Big Sur. And during the fire, I had to leave to come to San Francisco. So this is something near and dear to my heart. So I posed the question, do people settle after a fire? Do people resettle after deforestation? And how many years later do they come back? And can I get evidence of forest regrowth? So for this specific example, I used a specific area in Indonesia. It's called Genang Gede Pedrang National Park. And basically it was deforested, as in it was burned on purpose. For a variety of reasons, but using satellite imagery, we were able to figure out if people came back or not. What is your question for the planet? Let's have some ideas, and this time let's hear some voices. What do you care about?
What would the impact of large-scale solar farms in the Central Valley be?
Oh my gosh, that is an awesome question. Thank you so much for sharing that.
A similar one I'd like to figure out or show some scenarios that are basically following global warming targets, but showing where and how much solar would need to go where, and looking at the social equity side of that.
That is a very good question. Wow. I think we should write this all down. These are great questions. Urvish Kumar, I believe you raised your hand.
With the geospatial data information available, what is the percentage of a deforestation that's taking place, and as well as what is the part of the deforestation that is being utilized for the betterhood of the energy production, and as well as for implementation of different recyclable energies?
That is a very good question. So did you have a specific country or is the economy in mind? So are we talking about United States or a different part of the world?
With reference to the United States.
Got it. All right, so are there any other ideas? What is your question for the planet? Jennifer?
The impact of food availability in the United States should the water supply to the agricultural areas in Southern California stop?
Wow, that is such a great question. I also want to know the answer to that question. It's such a great question. All right, James.
I posed this in the chat as well, but I'm wondering are we deforesting the planet at a rate faster than we can sustain with the regrowth of older forests? And I'm particularly thinking of the Amazon rainforest in Brazil.
You know, that is a great question. And the most interesting thing about the Amazon rainforest, when you use satellites, ding, 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 everybody gets a prize if you get the right answer. But when you use satellites to look at parts of the Amazon rainforest, there are a lot of clouds. And I think the clouds affect the kind of images that you can actually take of the Amazon rainforest. So you might have to deploy drones, but that is something that, you know, computer vision scientists have to work around. So I think it's a great question, but you might have to consider that artifact.
It'd be a good one for JEDI, though, to connect it to your prior topic. Because
No.
JEDI can see through clouds. It gets you tree heights
Okay,
and density through clouds.
that's an interesting comment, because in my experience with JEDI, that's the claim that has been made, but it still doesn't work out, because I guess what people anyways, well, this is for another discussion, where I guess we're going deep into the forest, you know, ironically, but I guess we can have this discussion at a later time. So anybody else want to share some ideas? All right, I guess we'll move on. Okay, so what have people done? So, well, I think there are different techniques in machine learning. You can use computer vision, and most of this is computer vision based. We can use natural language processing. We can use time series analysis, causal inference. There's several techniques. So on the top of the chart, we have several techniques, and on I guess the rows of the chart, we have electricity system, transportation, buildings, industry. We have tons of different, so people have used machine learning, and machine learning is being utilized in everyday lives. Has anybody here worked on any specific system? Have you worked on any specific product that you want to tell us about?
I'll take that up. I think the solar solar geoengineering, and as well as, you know, with particulars of farms and forest, with specific to the recent engineering technology with the Federal Aviation Administrations, what has been brought as a part of the technological platform is that, you know, how to manage the farms and forest, and as well as the revitalizing the energy resources, as that, you know, how they are revitalizing those areas with being monitored through the drones, and as well as having considered to be a drone flying areas, and doing a data science through the land mappings and zone mappings within the flying zones. That's something very interesting. That's something very interestingly run through the data analytics and data science. So, thank you for.
Yeah, that's a very good response. Thank you for speaking up, because I think, you know, machine learning is affecting various areas of life, and ultimately we're looking for data, and we have a lot of data via satellites, and we're figuring out how to use them. So I wouldn't call it a blunt hammer just yet. I would just say we're more or less, we need to start with questions first and then decide on our tools. Okay, so there's a question in chat. No project, just reading. Okay, thank you, Bill. All right, so I think when it comes to sustainability and decision making, I know we only have 10 more minutes, so I'm going to go through this really quick. So when it comes to sustainability, let's go straight to why I'm bringing up satellite imagery, because it's low cost and it's globally available. It's available for free. So this is free data that we can utilize, and you know, if we know how to process these images, we can get a lot of information out of them. But the challenge is it's unstructured. So how many of you know what unstructured data is? You don't? Paul, do you know what? No?
I don't know. Not in rows and columns, I guess. I don't know.
That is the correct answer, actually.
Well, if I may,
Yes, please.
the unstructured data means there are a lot of geospatial information that has been unmapped, like a dome, like archaeological sites that still be present on the land, but still not being mapped, and information is available physically, though not geographically over through the satellite mapping. That's structured versus unstructured, still to be developed.
No, that is also a right answer. I think you're a few steps ahead than anybody else in the industry. Thank you for that. But I think, well, when we go back to Paul's answer, it means it's not something that is, we can use it readily yet. So we need to use a step called pre-processing. We need to use a step called pre-processing to make that data usable. You had a question?
I was going to add there was a lot of different types of unstructured data, not just data in images, but data generated from text files, documents, sensor data from the Internet of Things, data in social media, data stored in random communications like email, video files, audio files, server logs, website data, and of course in images.
I think as you all pointed out, this data is in a format that we cannot readily make. Is everybody in agreement? So yes, we have data, we have a lot of free data, but it's not enough format that we can use yet. So that's why we're using the tech. Even before we use machine learning, we need to go through a few steps called pre-processing to make it in a format that we can utilize and analyze it. Is this something that everybody here can agree on? Yes?
I mean, of course, yes.
Awesome. I think, as I believe Bill, sorry if I didn't remember your name right, I believe Bill pointed out, we can do all kinds of remotes, kind of, how salty the ocean is, the color sea state. We can look at all kinds of things regarding climate. So my focus is climate, but, our focus in sustainability can be a variety of things. And I'm skipping through these slides because, this is obviously a much longer presentation. All right, so Google Earth Engine. So it's free. It's from all over the world. Data is taken every 2 weeks. Some satellites like JEDI, it's over 5 days. And the resolution is about 10 to 25 meters. And we have free access to Landsat and JEDI from NASA. So 10 to 25 meters. So who here can tell me if, we can say, look at a plot of land? Can we look at a house? What is the size of land that we can?
Pretty big, like a field, not a house. I mean, or barely, maybe a house, but barely. It would be a spot. Couldn't see cars, couldn't see people.
I think it is that we're actually looking at our kind of low resolution images. I guess the point I want to make is that we have to be realistic about the kind of data we can get. So I believe, like one of our friends on this call said, a house would just be a dot, but maybe something size of a field is probably what we can resolve. So that is something we need to be very realistic about. All right. Okay. So without going into, so like I stated, it was actually a longer presentation. So my approach for looking at if people actually came back to this place in Indonesia was just looking at lights. So then that's what we call proxy data, which means at night, if that area has more lights, then more people are coming back. So I looked at satellite data over 5 years, and it looked like there were more lights coming up at night. So it might be the same person building a whole lot of houses. I guess that's a variable to consider. But the other variable is that, there are people settling in this part of town after the reforestation. So people are settling back. So the take-home message I want us to go through is unstructured data and labeling is an issue in climate change. So, that's one of the reasons I use proxy data. How do we know if people are coming back, if people are leaving? So we have to find a way to label. So these are two main issues that we have to consider. But the good news is satellite data is free and they are large data sets and we have ways of compressing them and we have larger computers now. So roughly, we have more computing power. So that's a good, I guess that's a positive in our favor. We need to frame our problems clearly. Like, what are we studying? What are we looking for? And definitely in this class, we'll look at data cleaning, image pre-processing, and what machine learning tool to use. So depending on your problem, you might have to use a different machine learning tool. But I think ultimately, it all ends where you can appropriately explain what your data means. I think that is the take-home message. So basically, the idea of this class is to build an AI portfolio. We'll use Keras and MLOps, so this would be end-to-end. So I'll give you a lot of tools and resources like SageMaker to develop an end-to-end solution. And I believe this is for Maira.
Yeah, so I will drop again the link for those who joined us after we started the presentation. So AI for Sustainability is on the chat. You could click on the link to register for the course. And if you have any questions, you can find our email and phone number there. Also, coming up, we have AI application development specialization. So this is for anybody who wants to specialize in AI. That is a program that we offer for a total of 9.5 units in 4 courses. So the business of AI, introduction to machine learning, Python for machine learning, and artificial intelligence essentials, artificial intelligence for robotics, and GANS for data synthesis. So for anybody who's interested in any of those courses, you could take those courses to get an AI specialization from UC Santa Cruz Silicon Valley Extension. So that is pretty much it on our end. Unless there's any questions that you want to stay and ask, we could stay for a few more minutes. But please feel free to email us or give us a call if you have any questions regarding either the program or the course itself.
Just one question, is it an online course?
Yes, so this course will be provided online. It is flexible, which means it has an option for in-person learning or the remote live online. And Saturdays from 9 to 12.
Are the prerequisites listed on the website essential, the Python for machine learning and the introduction to machine learning?
Dr. Shalini, I'm gonna lean on you for this question.
So I think, you can also use R. The main objective is Python. Obviously, if you're an experienced developer, Python has other libraries like PyTorch that you might want to use. So I would highly recommend it. But if you have other skills, we can work with that as well. So I wouldn't say it's a make or break, but I would say I would highly encourage you learn Python.
Thank you.
No worries.
Thank you very much again to Maira and Shalini. I wanted to acknowledge the UCSC Silicon Valley Extension's Artificial Intelligence Program, and also wanted to acknowledge what Shalini's presentation is about. I think it's a niche topic, and if there is any further advanced courses that can be, I see that there are 4 courses. So each course 9.5 units, but this is the only course right now that's been starting from July 9, if I understand correctly, right? This is the first course, right? There are 4 courses in that.
There's not 4. What do you mean 4 courses? There's 4 courses. Actually, the AI application development program, that specialization is 4 courses of its own. Some of those are listed here, but this class that Shalini's teaching is actually not part of that program. The specialization is really focused on building apps for the enterprise. And this is just another AI class that we're teaching.
I went ahead and dropped the link for the specialization in the chat. So if you want to review, we have several classes that are open for enrollment in there as well. From the summer, some of the courses are starting in July all the way through the fall. So if you want to take a look at our catalog there.
Sure. Thank you. That's what I was looking for, that whether this is the only class or there are other extension classes are there or not. Thank you.
Yeah, I can put in the chat the AI program. All these are a bunch of classes that we teach that are for the AI program. So the specialization is part of it. Shalini's class is part of it. But it's a pretty fast growing program. And we're also working on a employer practicum right now that will allow students to work on a project that is a real project with an employer. So that's hopefully coming down the pike in late summer, I think.
All right. Any final questions before we say goodbye? Go ahead, Miguel.
I wanted to wait until the end because it's a little different. So I am part of a search and rescue team. And the reason why I called in is to see if I would be able to use, I take a lot of pictures with drones during searches, and I stitch the pictures together. And I was wondering if this class will allow me to do a search, say looking for a backpack or looking for a person. So I don't know if this is the right class for that kind of a thing.
100%. I would say so. Basically, if you already have the images, then so you're, am I understanding this correctly? You already have the images?
Yes, I take them with a drone.
Okay. Oh, wow. Okay. So can you tell me what the resolution is of your images?
Usually about, it's about 3 inches per pixel. So, 12 megabytes, 12 megapixels, I mean. So it's pretty, I can see a person pretty well. I cannot see the facial features, but I can tell, the body and the head and the arms. Yeah.
No, I think this would be a good class. Obviously, if you have the so that is the purpose of the class. So you have the images already. So the way we would guide you is you have your images. We would do some pre-processing on your images so that we have to decompress it, and then we have to find the right machine learning computer vision algorithm to figure out what it is you want to determine. This could be a feature selection, a feature extraction, or you just have to build some features. So we're gonna figure that out, and then the next step you would do something called classification. So is this person hurt, or the final question that you're asking, hurt or not? But I think this is a very interesting project that definitely falls in this category.
Okay, thank you. Thanks.
All right. Anybody else? Jennifer Palma, I'm not sure if I kind of got you trying to ask a question before.
Yeah, I think I'm good. I personally have experience with Python, but not machine learning. So I'm just trying to determine if I should take that one before I attempt this class.
Well, I think if you have a question, then sometimes having a use case and working through that use case is kind of how you learn machine learning. So you can learn a whole bunch of techniques and not know how to apply it, or you can actually have a purpose. So if you know Python and you have a purpose and you work towards it, then you already have learned a bunch of machine learning techniques. So this is my suggestion, but of course you have to do what you trust is correct.
Okay, thank you.
Awesome. Well, with that, thank you so much, Dr. Shalini, for all this great information on AI and sustainability. And thank you all for coming and joining us.